Through the 15C assignment. All right, so we'll start with number 1 here by using truth tables as we did in example 5. Establish that not P or Q equals not P and not Q. All right, so what we want to do first is set up our truth table here. So we want to start with P and then Q. All right, and we make our little things here. And then when you make your tables, you just want to remember that you always start with the far right one and just go true, false, alternating. And then as you move back to the left, you just double that each. So now you've got, instead of 1 true, 1 false, now you've got 2 trues, 2 falses. And that should get all of the different possibilities. So I usually try to start with what we have here first. So we have P and Q. Now we want to know what P and Q is first, so let's do that. Let's do P or Q is what that stands for, and that's this piece in here. So we'll do that first. So P or Q, as long as one of the two of them, at least one of the two of them is true, then it's true. So that's true, 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 and false. So then not P or Q would then be exactly the opposite of that. So that would be false, 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 true. Okay, so that's this one. So that's one that we want to remember. And then we also want to figure out what not P and not Q is. So first thing we'll want to do is we need to know what not P, and we also need to know what not Q is. So not P, it's just going to be the opposite of this P column here. So we've got false, false, true, true. All right, and then not Q is going to be the opposite of the Q column there. So false, true, false, true. Okay, so then now what we want to do, now that we know not P and we also know not Q, now we're going to figure out what not P and not Q is. Okay, so not P and not Q. So they both have to be true in order for this to be true. So that would be false. There's a 1 false in there, so this is false. There's a false in there, so this is false. And there's 2 trues. This is the only one that's true. Okay, so this is the other one we wanted to look at. So they say let's show that these two are equal. So now we just look at these 2 columns and notice that this is false, 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 true, false, 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 true. So we now have shown that these 2 are equal, right? So we know that those are logically equivalent. Okay. Moving along to number 3, use De Morgan's properties to find the negation of these things here. Okay. Okay, so this one here, let's take a look at A here. Ooh, got a goofy color going on there. All right, so we've got x equals 4 or x equals 5. So really it's this De Morgan's property is really pretty much just, we're just trying to find the negation of these. So what we got is then is going to be x does not equal -4 or x does not equal 5. Okay? And actually this here in the middle, instead of or, it really officially should say and. Okay, so we're switching the ors to ands and the ands to ors, and we're basically just flipping everything around when we're doing our negations. Okay, let's see, let's do B. 5 is less than or equal to x, which is less than or equal to 9. So really what we're going to do is we're going to flip those both around. So we've got 5 is greater than x, and x is greater than 9. Okay, and we really shouldn't write this as a compound inequality because x is less than 5 and x is greater than 9. Those are not going towards each other. They're if you were going to graph those, which again they're not asking you to, we've got 5 and 9 on a number line here, and what those are going to look like is x is less than 5 and x is greater than 9. So it's going to look like that. So that's why we wouldn't want to use a compound inequality on that one. Okay. C, x is now going to be greater than or equal to -1, and x is also going to be less than or equal to 7. Now this one we actually should write as a compound inequality because x is greater than -1. So again, if you're going to graph that thing, here's -1, here's +7. So these are actually heading towards each other. So that's why this would be a better one to write as, put x in the middle. We got -1 out here and 7 out there. X is greater than or equal to -1, but it is less than or equal to 7. Okay? All right. D6. Identify which of the following compound statements are tautologies, which means that they are all true. Which are logical contradictions? These here are all false, and then which are neither? The neither is some kind of combination of trues and falses. Okay, so look, we got all sorts of fun stuff to work on here. So let's start off with everything is, let's see, we got P, and we do have one Q at the very end there. So I'm going to do P and Q. All right, so P, let's see, Q is true, false, and then P is true, false, false. Okay, so first thing we need to know is not P. So not P is going to be the opposite of that one, so it's going to be false, false, true, true. So then what we have to figure out now for part A is not P and P. Okay, so not P and P, that's these two here. So we want to ignore the Q one. So true and false, if it's and, they have to both be true, so that's false. True and false is false. False and true is false. False and true is also false. So that makes this one a tautology. Oops. I believe it's just tautology like that. Okay, that is a G. Looks like an S, and it looks worse, but you get the idea. Okay, so that was A. For B, we want to know P and P. So we have P already. So let's do P and P. So this is part B. So P and P, so it's true and true would be true. True and true would be true. False and false would be false. False and false would be false. So this one then is neither. Okay? Okay, I'm going to back up here a little bit because I wrote the exact wrong thing over here. I wrote that it was a tautology when it's actually a contradiction. Sorry, when they're all false, that means it's a logical contradiction. Sorry, I wrote the exact opposite. If they're all true, which none of them are, that would be a tautology. So, logical contradiction, okay, is this one. Okay, sorry, move. Number 5, represent the following on Venn diagrams. P exclusive or Q. All right, so for this one here, we've got, draw a couple circles here. We've got P and we've got Q, okay? And remember, exclusive or means that it's got to be in P or Q, but it can't be in both, okay? So a couple ways you can do this. Let's try this. We're going to do P. So here's P. And then let's do, say, here's Q. All right, so there's our Q. So the solution then is going to be everything that's shaded in except for the overlapped piece. So this overlap piece here can't actually be in there. So what we have to do is we have to actually erase that overlap piece. So that's what our solution would look like. This one, but not the middle and not the outside. Okay, let's take